Okay, so our goals for this lesson are to use the law of cosines to solve a triangle, find the area of a triangle given two sides and an included angle, and find the area of a triangle using Heron's formula. So first, let's look at the law of cosines. So you're going to use the law of cosines when you know all three sides or two sides and an included angle. So these are the three law of cosines formulas. You'll have a squared equals b squared plus c squared minus 2bc cosine of angle A. So this would be your two sides would be b and c, and your included angle would be A. For the other two, your two sides that would include your angle, so it would be A and C would include angle B. And for this one, A and B, your included angle would be C. So you either need to know all three sides to solve for an angle, or you need to know the two sides and its included angle. So let's try an example. So I want to solve using only the law of cosines. So this is a side-side-side triangle. We have A equals 9, B equals 7, and C equals 5. So we can label the triangle A, B, C. So those are our angles, and the side is always opposite its angle. So side A is always opposite angle A, side B is always opposite angle B, and side C is always opposite angle C. So I know these three sides. I want to find the three angles. So we can use the law of cosines to find these angles. Let's start with a squared equals b squared plus c squared equals, minus 2bc cosine of A. Now we could have picked any of the three because we know all three sides, but I want to start by solving for angle A. So we'll get 9 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of A. So now I'm going to put this in my calculator and do a little simplifying in the process. So I'll have 9 squared minus 5 squared minus 7 squared. So to start over here, I moved my 5 squared and my 7 squared over. And you'll get 7 equals, and then negative 2 times 5 times 7 is negative 70 cosine of A. And here you can divide, and so you'll have negative 0.1 equals cosine of A. And so we can take the inverse cosine of negative 0.1 to get our A. So I take second cosine, so inverse cosine of 0.1, negative 0.1. And that says A equals 95.739. Now, I want to always use stored and exact values. So I'm going to put in a little asterisk here to say I'm storing this value. And to store the value, you're going to go down here where it says store. You hit store, and then I can hit alpha, and then A. And this will store this as A in my calculator. I'll hit enter, and it's saying it is storing this value as A. So now whenever I want to use this value, I can just type in A. So let's try. So we know that A is 95.739 degrees. Don't forget that degree symbol. So let's solve for angle B. So I can use b squared equals a squared plus c squared minus 2ac cosine of B. Okay, so b squared is 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of B. So you put this in your calculator, you can get negative 57 equals negative 90 cosine of B. So then I get 0.633 repeating equals cosine of B. And so when I put this in my calculator, I'll do the inverse cosine of that negative 57 divided by negative 90. So that gets me to be B equals 50.704 degrees. And I'm going to go ahead and store that value as B. So B is 50.704 degrees. And now to find angle C, I can take the total degrees of my triangle, which is 180, minus my stored A value, minus my stored B value, supposed to go on this side, minus my stored B value. So I can just type in here 180 minus my stored A value minus my stored B value. So I just typed in alpha A, alpha B to get those. And so that leaves me with C equal 33.557 degrees. And so therefore I've solved for this triangle. So now let's look at another example. So this example is going to be side, angle, side. So I can label my triangle of A, B, C. So I know that side A is 10. I know that side B is 12. I know angle C is 50 degrees. So I have my two sides and an included angle. So two sides and an included angle. So now I want to use the law of cosines to solve. So I can do C squared, because I want my included sides to be on this side. So C squared equals A squared plus B squared minus 2AB cosine of C. Okay, so this is going to let me solve for side C. So I'll be left with C squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 50 degrees. So now I'll put this in my calculator and I'll get C squared equals 89.731. And you want to make sure you practice putting this in your calculator so that you can get it right on the test. Make sure you practice storing those values. So I can store my value C as 9.473, so I took the square root of both sides. So that gives me my C value of 9.473. So now I want to find my angles. So for my angles, I can use my law of cosines again, and I'll be left with, let's see, I can do 10 squared, so I'll use my A squared equals B squared plus C squared minus 2BC cosine of A. So here I put in 10 squared equals 12 squared plus my stored C value minus 2 times 12 times that stored C value again, cosine of A. So I can put this in my calculator and I'll get negative 133.731 equals negative 227.343 cosine of A. So that leaves me with 0.588 equals my cosine of A. Take the inverse cosine, again using the answer or the stored value. So I'm not actually using this value, I'm using the stored value or the answer value that is in my calculator. So that gives me A equals 53.968 degrees. And now to get angle B, I can take 180 degrees minus my stored A value minus my C, which I already know is 50 degrees because that was given to me. And then I'll get my B value, so that gives me B is 76.032 degrees. Alright, so make sure you practice putting these in your calculator so that you can get these answers out and practice storing those values. So using the law of sines may not give us a valid triangle, so you always have to check. Although the law of cosines is more tedious, you'll always get the right angle due to its restrictions. So cosine inverse is restricted from 0 to 180 degrees in any given triangle. You will never have an angle greater than 180 degrees. So whenever you use the law of cosines, you will get the correct angle measure. Now the law of sines is a lot easier to use than the law of cosines, but there are some issues we need to consider. So let's look at another example that addresses what issues we might encounter. So we have a triangle with angle B measuring 35 degrees, and we have side A is 43 and side C is 19. So we can use the law of cosines to solve for our B, our side B. So we have B squared equals A squared plus C squared minus 2AC sine of B. So I'm going to plug in the values that I have. I'm trying to find B squared. I know A is 43. I know C is 19. So I can plug those in. And I know B is 35 degrees. So I plug that into my calculator and I get 871.506. And I'm going to store this value in my calculator as the square root of that. So I get B is 29.521. Okay, so now from here we can use the law of sines because we have two sides and an angle. So we want to find the side opposite an angle. So we can say that sine of 35 degrees over this stored B value. Make sure you're using those stored values. Equals the sine of A all over 43, and that'll give me the sine of A equals 0.835. So my stored A value 56.664 degrees. So then I can take 180 degrees minus my 35 degrees minus my stored A value, and that'll equal my C value. So that gives me, so A is 56.664 degrees, and that gives me C of 88.336 degrees. So now there's something that is not quite right about this triangle. So let me put these values in. Hopefully maybe you can see it. So this is 56.664 degrees. This is 88.336 degrees. And this side B that we solved for is 29.521. So with our triangles, this triangle is not valid. It doesn't work. We got to make sure that the largest angle is across from the largest side and that the smallest angle is across from the smallest side. Here we have the largest angle is across from 19, but the largest side is 43. So that makes this triangle invalid. So how do we make this triangle valid? So we got to redefine our angle A, because angle A is the angle we found first using the law of sines. So we need to redefine A. So the way we do that is just like we did using the law of sines in the previous video. We can do 180 minus that stored value of A, and we'll get 123.336 degrees. So we can put our new ones up here. A equals 123.336 degrees. So then we can find we know that B equals 35 degrees, and we can find C by doing 180 minus our new A minus 35 degrees, and that's 21.664. And our original B value was good because we used that using the law of cosines. So now angle A is our biggest angle and it's across from our biggest side. And then angle C is our smallest angle and then it's good, it's across from our smallest side. So that checks out. So this is going to be the answer to this triangle. Okay? So using the law of sines may not always give us a valid triangle. You have to check. So although the law of sines is easier, you might run into this issue. And the law of cosines is a little more tedious. You'll always get the right triangle. So it's up to you to decide which ones you would like to use. So a couple things to remember. To be a valid solution, the largest angle must be opposite the largest side, and the smallest angle must be opposite the smallest side. Also, when two solutions are valid, you must have both solutions for it to be completely correct. If you not have both solutions, you're not completely correct. So the last thing we want to talk about today is the area of a triangle. So we can find the area of a triangle when we know two sides and the included angle. So the formula for this is 1/2 BC sine A, which equals 1/2 AC sine B equals 1/2 AB sine C. So for this, our two sides are B and C and our included angle is A. These are our two sides and our included angle. So depending on your triangle, it'll determine which one you pick. So let's look at an example. So we want to find the area of triangle ABC if A equals 2 inches, B equals 5 inches, and C is 110 degrees. So to do that, we'll look at our formula. We have the area of the triangle equals 1/2. We can use B and A, so 1/2 A times B sine of C, because our two sides are included angle. So the area of our triangle is 1/2 times 2 times 5 times the sine of 110 degrees. And you can put that in your calculator and then you'll get the area is 4.698. So this is going to be your answer. Okay, so pretty simple. Just it's another formula you have to memorize. But it has to be the two sides and the included angle. So our last way to find area is using Heron's formula. So Heron's formula is when you know all three sides. So you have to have all three sides. If A, B, and C are sides of the triangle ABC, we can let S denote the semi-perimeter. So the semi-perimeter is you're going to add up all three sides and divide by 2. So that's going to give you the value that Heron used to find the area of a triangle. The area of the triangle is going to be denoted by the square root of S times S minus the length of side A times S minus the length of side B times S minus the length of side C. Okay? So let's try an example with this one. So we're going to find the area of triangle ABC if A equals 13 inches, B equals 14 inches, and C equals 15 inches. So we need to find the semi-perimeter first. So we need to find S equals A plus B plus C all over 2. So S equals A is 13, B is 14, C is 15 all over 2. So that gives me an S of 21. And so now we have S, and we want to find the area of the triangle. We have area equals the square root of S times S minus side A times S minus side B times S minus side C. And so that'll give us a square root. If you multiply all this, you subtract these and you multiply all this out, you get 7,056. And that gives us the area equals 84. So remember, if this is a decimal, you're going to have to use stored values. Because we always want our exact answer. You want to round at the very, very, very last second. So make sure you're using stored values. If your decimal is off because you didn't use stored values, your answer is wrong. So if you did not use stored values, if not, your answer may be marked wrong. So keep this in mind. Alright, and that is it for this lesson.